All right. Thank you, Alice, Bruce, and Anna, and Julio for such an interesting discussion panel. I just want to take a moment to remind you all that this event is recorded, and I would like to encourage you to type your questions in the chat so that we can incorporate them into the panels. Our next event will be a 30-minute session on 3D printing construction, looking at all the possibilities and applications going on beyond housing, and then we'll transition into a networking session. I'm excited to announce that we have a never seen before panel between two speakers from companies who work very closely together in the industry, Justin D'Angelo from Printera and Volker Ruitinga of Vertico. I'll proceed by properly introducing Justin, and then he'll give a short 5-minute introduction to Printera, and then we'll follow up with the same for Volker and proceed to the panel. Justin is the founder and CEO of Printera, a concrete additive manufacturing company in South Florida, specializing in precision concrete 3D printing of architectural and landscape features. Justin founded Printera in 2021, and this has been his full-time gig since. Before Printera, Justin was an agile project manager overseeing projects for Royal Caribbean, HSBC, United Technologies, and more. He obtained a bachelor's in business management from Bentley University and has lived all across the world, including Singapore, France, and Australia throughout his time. And he is also the husband and father of 2 beautiful children. I present to you, Justin D'Angelo.
Thanks for that awesome intro. It's really good to be here, everybody. And I love to share the other capabilities of concrete 3D printing beyond construction. So our little header image is just a collection of different things we've done. And I'm going to just take a couple minutes to share some interesting projects and then move it over to Volker, who has the machine that made all of that possible, before just opening up to general questions and things. So if you want to jump to the next slide. So you may be asking, what other applications are there beyond beyond construction with concrete 3D printing? And this is just a small list of different capabilities with a couple images of things we've done. But it ranges the gamut from small elements like planters and things that you would have in a consumer backyard to larger architectural features in communal spaces and cityscapes. Next slide, please. The key in this specific niche, though, is it needs to have a superior quality, right? So precision and quality are king. And I'm sure Volker will talk a lot more about that with regards to the machine. But when you're doing things in the architectural space, we want to bring the final product as close to a completed item out the door as possible, right? We want to eliminate as many downstream processes and additional working. So we have complex geometries, right? Layer quality and consistency are what we were looking for, and the implementation of changing color and tone as you're printing. Next slide, please. So I'm just going to touch on 4 projects from just a very high level standpoint. So looking at residential, right? Everything from columns that you would see supporting the front of a home to artistic statue bases and outdoor furnishings. Really great for South Florida, by the way, because we like to say they're hurricane resistant. Next slide. Moving into the commercial space, I'm really excited to share this. This is the first time anyone's seeing this project, but it's an entire coffee bar printed downtown Tampa. Again, we print everything in our facility in Stewart, and we deploy it around the country. So as you can see, serving surfaces or seating bars, implementations of nice curves and patterns, Voronoi type of shapes and infills. So again, this is bringing a lot of creativity and design back to these public spaces in an affordable way. Next slide. Moving beyond that to even larger spaces, I'm really pleased to also debut this project that we have ongoing right now. We're actually printing it this week and through the end of the month. Large architectural benches dividing public spaces. So this is going into 25 Water Street in downtown Manhattan. Again, the culmination of multiple printed elements together that create one 60-foot element in a public area like this. So again, it's bringing that creative flow and organic freedom to those communal spaces. And I think we got one more. Next slide. And I'm sure you're going to hear from this speaker shortly, but this is the marriage of 2 3D printing technologies in one project. So the world's largest 3D printed structure is presently in Wellington. That was printed by Printed Farms, and I'm sure he has a lot to say about this, but our particular participation in this project is in contributing the columns. So there's 30 columns around the structure, And we were really thrilled to be able to work with another 3D printing company, leveraging the benefits of both technology sets to come together in one finished project that is really quite awe-inspiring. And yeah, we'll keep it short, and I'll turn it over to Volker. And there's my contact info, by the way. I encourage anybody to feel free to get in touch.
All right. Can you hit the next slide, please? Thank you. Thanks, Justin, for that overview of the really unique work that Printera is doing. I actually had the opportunity to travel from Georgia Tech to Printera's headquarters myself a couple of months ago, and I saw several of the prints in person and even Vertico's robotic system in action. I must say, the quality of the prints achieved are among some of the best that I've seen in the industry. Next up, I'd like to introduce Volker, the co-founder and CEO of Vertico. While working in the automotive industry, Volker became fascinated by 3D printing. In 2018, he started Vertico in an effort to upscale the 3D printing process. In using concrete as a new printing material, he saw the opportunity to combine his love for additive manufacturing with his appreciation of architecture and design. He holds a degree in philosophy from the Erasmus University, and just like Justin, is married and the father of 2. All right. There you go, Volker.
Thanks, Jared. Yeah, Justin and I have somewhat of a similar background, not only wife, 2 kids, but also lived abroad a lot, and are directly from the construction industry. So, we disrupt the market like that. When I started the company too, I had no technical background, no concrete background, no architectural background, but that also doesn't inhibit you from making something new, right? And that's what disruption is really. I'm here to present a few slides just to make clear to the audience what the difference is in what we do compared to the construction printing of housing. So feel free to go to the next slide, Jared. Our company does 4 things. Basically, we sell hardware. That's our main business, but we also do printing in-house. We do software alongside that for both robotics and the design and the slicing, etc. And a lot of consultancy, because the projects that are coming up now, new projects, the market doesn't know what's possible yet, so we do a lot of prototyping, etc., which is a typical 3D printing application, rapid prototyping. Yeah, go ahead and show the next slide if this works. I hope it doesn't lag too much for you guys, but I wanted to show you a little bit what it looks like to 3D print with what's commonly known as a 2-component technology. This is accelerated concrete printing. This is our mixer. Our mixing version is a continuous mixer with a very long mixing chamber. And we print in-house only. We focus a lot on monitoring and on automation and on user friendliness. And it's a pre-fab solution. And we do a lot of these architectural, special, weird sort of projects and capabilities. So as Justin said as well, we focus on high detailing, high quality, and we can print extremely small bases, so we don't need a very long time before we can stack the next layer. You can see how small we can go for columns. We're adding the color now, and in these photos you can see what type of overhang we can achieve as well. So we're able to do pretty extreme angles and make much more intricate shapes than the traditional sort of construction 3D printing can. So what's different about our technology is that we add our accelerant at the print head. So we pump our concrete mix, and then only at the print head is the accelerant added. One of the key benefits of this is that even if you have an issue, there's nothing hardening in your system except at the print head. If you have an issue with a larger gantry, for example, your concrete's already setting in your pump, and we don't have that. That makes our material much more liquid when it comes to the print head, which is also important for pumpability. So you can imagine on a large house, it's quite difficult to pump 3D concrete material over a large distance. And with our material, that's not the case. Go ahead, next slide. I think in doing this, we focus basically on in-house printing only. This is especially also to control environmental conditions. So we developed technology with a lot of, as I said, software for monitoring. So we can interact with the machine as it's printing. If there's a problem, you can see, with the temperatures development of your concrete, you can act. And then we're also adding new features such as color, start and stop, rotating print head, etc. Next slide, please. Important to talk about is the sustainability aspect, and that's difficult for concrete printing because of the high cement content. We've heard this before, but I wanted to share with you a few sides of the coin or the equation that we tend to focus on. First of all, on the left is the material optimization, and we're able to use organic shapes, biomimicry, and optimization, just like in normal 3D printing. One of its main advantages to make shapes and structural forms that require less material. At the same time, we can do a reduction of formwork, so people underestimate how much wood goes into concrete pours as well. You don't see it once it's finished, but when it's used, there's a lot of wood and material that goes inside, and we can actually create, like this pavilion was made with zero formwork whatsoever. This is all temporary scaffolding. And lastly, there's the alternative materials. Julio from WASP already touched on this. We work with Regulus for Mars projects, but also EcoCrete geopolymers. And we're happy to switch to anything more eco-friendly and try those on our machines. We don't have a proprietary material. We have our own mix, but it's open to use for anyone or any material. Next slide, please. I wanted to touch quickly on that optimization. So what we do is we take a bridge and we say we want to go from A to B, and the computer calculates in voxels what material can be removed. In the simulation, you can see on the next slide, Jared. If you click one more time, you'll see an animation, hopefully, of the simulation, and you can see where. Oh, doesn't matter. It's not simulating. It doesn't matter. You can see here where the stress points are, and all the white space is material that we can remove. So when you go to the next slide now, you can see the final product is a optimized bridge, which is very much like a tree in the sense that it doesn't use more material than it needs. It only uses material where necessary. And 3D printing is uniquely situated to make these curves. Next slide. Form freedom is another thing we use a lot. I always say in 3D printing, it's not because it's 3D printing that people buy it. That's only me and people that are in the industry. But it has to be 3D printing and something else. And it can be 3D printing and structural optimization, or 3D printing, and in this case, aesthetics. So it just looks amazing. Next slide. We'll keep it short. You can see in these photos we showed before, this is a concrete canoe, which we do with students every year to kind of push technology and see where we're at. This is the 4th iteration, so we keep making better and better prints. And then the last slide, one more. You can see sort of the range. We can do architectural things, interior projects, seating outside, lounge furniture. These are the kind of applications that are common now early on. And finally, we have some contact information as well for anybody interested in machines.
Thank you, Volker, for the overview
Yeah.
of your company and the systems you guys produce. I think it's really interesting, personally, that you adapt already fully built and proven robotic machines to work optimally for 3D printing. We'll now transition this segment into more of a discussion-based conversation. I have a few prepared questions for you, and I'll try to work in some from the audience as well as we go about it. So my first is just more of a general question that goes both of you guys. Collaboration very clearly seems to be a very significant aspect of your work, as evidenced by your joint projects and Printera using the Vertico system. Can you share some insights into how collaboration between your companies has enhanced the development and execution of these projects, particularly in terms of efficiency and the creative aspect?
That's you, Justin.
Okay, I was wondering who it was directed to. Okay, cool. Yeah, I mean, look, at the end of the day, when you purchase a system, right, a concrete 3D printing system, a lot of people go into it thinking, hey, this is a 3D printer. It's going to be very easy to get off the ground, and you know, I'm going to be printing, you know, 2 days after the machine's installed. And the reality is, every panelist on today's meeting will agree that it's a little bit more complicated. And a lot of it comes down to the level of integration and support that you get from the machine supplier. So, you know, Volker and Vertico have been excellent in that regard, because there's a level of integration that occurs at the time of installation, but then support throughout. So as we look at, you know, designing for projects in various applications, whether it's structural or non-structural, just opening up capability and leveraging on their learnings to be effective in our prints is a really key element. And then even looking at how we can how we can integrate together from the standpoint of running the same system, right? It stands to reason Vertico running the same printer with, albeit a slightly different material, if they can print something, then it stands to reason that we can do it too. So there's been sharing of actual printed elements to facilitate easier bids and working with end clients on that kind of mutual portfolio.
Yeah, if I can, I can add too. I think there's a lot of students on the call as well, so it's good to share a little bit like where this came from. And Justin is a typical example of someone that started to pioneer in literally his own garage, right, in his shed. And I remember our first contact with him emailing me with a photo of his setup and being like, is this right? And I was like, yeah, this looks good, that looks good. I would change that from experience and whatnot. And then like a year later, he emailed me again and he showed me what he was doing, and I was really happy to see his progress. And then he went online and he found a website I created called Slicer Excel, which is a free slicing website for large scale gantry and robotics. Because when I started the company, I had no idea how to slice an object, because for large scale that didn't exist, and it was a big hurdle for us. So I did a hackathon and we created an open source slicer. And Slicer Excel is like a free version for pioneers just to get started, right? For cheap. And then he emailed that website and he got a reply from me saying, hey, it's me again. And, use it in this way. And then we were talking about materials and he said, hey, I had this material, what do you guys use? And I said, well, we use such and such. And he goes, hey, that's exactly the mix I had, because that's the mix we put online once in the early days as an open source material. So it kept coming back and back to us, because if you share a lot of the information and if you take away the initial hurdles, it really helps people to get started. And that's important in this phase of the innovation. We shouldn't forget that this isn't a mature market yet. And people that think 3D printing is magic, it is, but that doesn't make it easy. So that type of collaboration is super important, to be open and to share information.
Thanks. Justin, I'd like to go back to the really impressive finished quality that Printera has been able to achieve with the Vertico system. What quality measures can be put in place to ensure that you have viable and consistent products that you guys are putting out?
Sure. So, I mean, first of all, it all starts with good material, right? There's a breadth of material. I think the last panelist mentioned, right? There's multiple sources, but that's the foundation of any print. So presently, we're working with Quikrete, who's been really good at generating material for us, and Bing is a panelist later this afternoon, it looks like. So you'll hear from him. I won't talk too much on that. But with regards to the actual print quality that you're going to get outside of the control of the material, you need to control the environment, right? And you need to be monitoring not just the environmental factors, but the real-time factors as they pertain to the print. So examples of that is that the Vertico monitoring system actually returns data in real time on 17 different metrics on a screen that we're looking at over the course of a print. And these are things like the pump pressure, the temperature of the material at different stages throughout the system, the level of accelerant that you're injecting, the temperature of the nozzle, because it's an exothermic reaction that all of this printing is doing. It means that even if you have consistency in every other element, over the course of a print day, your heated up nozzle is going to have that reaction occur faster. So you need to adjust for that with a change of accelerant. So there's just all of these different data points that we're watching over the course of a print to make sure that we get a perfect print nearly every time. And then obviously not fighting against the environment is a big help too. So that's also why we're indoors, right? We're not trying to be on a site and contend with rain and snow or whatever you have. So I hope that addresses the question.
Yeah, no, I think that was a great answer. Volker, so it seems evident from your presentations that Vertico's focus is on creating 3D print systems that are targeted towards applications other than housing. Why did your company choose to do this? And why have you guys chosen to veer away from housing? And what's your perspective on the best applications of this technology?
That's a good question. So when I started the company, we started with a robotic arm, and one of the projects that I watched closely was a project in Germany for printing a 2-story house with Peri, and friends of mine printed that. And I know that the material alone in that construction was close to 100,000 euros, and that's the concrete printing material only. And when I started the company, we had no funding, still haven't had any external funding, and I didn't have any money, so I didn't have 100,000 euros lying around to print a house for fun. Like, it just wasn't, it wasn't happening. So we decided to go for smaller things, and that also applies a lot to our, what my interest in design and architecture, that kind of side. But as we grew, we had to make the objects higher and higher quality, and we went for the 2K system, which was around a little bit back then. We were very early with that. And what that unlocks for us is that form freedom that you get with 3D printing. And I was into 3D printing for a long time, as you said, as a hobby of mine. And I think that 3D printing at this scale, in the 2-component side, mirrors the advantages of 3D printing the best. So gantries and printing houses, I encourage anybody doing it, and it's an impressive feat. But it doesn't necessarily touch on all the advantages of 3D printing in general. And like the rapid prototyping, the weird forms, the shapes, the speed, and this is very important to have. So that's something we focus on a lot. And I think there's just a lot of applications there. So as we've mentioned, we do, in-house sort of the precast industry, because we need to control these environmental conditions, right? We want to make the best prints in the world. And in order to do that, I want as little variation as possible. So when you print, and Justin will know this, we actually don't adjust a lot of factors when we print. If the data is going haywire, your print's failing. There's not that much you can do. You need a consistent print to begin with, right? So we do use the data a lot to kind of steer, how's the curing going? Do we need to put some less accelerant in to keep the temperature down a little bit? But it needs to be perfect and smooth, just like a desktop printer. If things are going haywire in that, the print will fail too. So once you're printing, it's usually very, very smooth sailing, but the data will tell you why it's going wrong or why it's gone wrong. And I think that's very important.
I think that's a great transition to my next question, which is, could you guys, both of you, like, elaborate on why you guys are fans of the in-lab, like, prefabrication method of 3D printing, and then possibly, like, go into some of the unique, like, advantages and challenges of doing that. So, like, what are you guys sacrificing by doing it in lab versus out? Yeah.
So yeah, I'll jump into that one first as well then. So I think we already did a really good job of touching on just environmental control, right? So even in plastic printing, right? If you put an enclosure around your printer, you see a visible increase in the quality. So just taking that to scale, it's extrapolated even more so on 3D print material, right? Concrete mortar is very sensitive to those environmental conditions, and having the ability to climate control and monitor humidity, as well as just the suite of sensors that we're running. And to Volker's point, while a lot of adjustments over the course of a print are not necessarily necessary for each print, it is something that we're capable of, and it unlocks additional freedom, right, in terms of the ability to print. So if you're printing non-planar, for example, you can increase or decrease the extrusion rate on the system depending on what you're doing, right, as the nozzle is oscillating up and down. Touching on the challenges, of course, that means that everything that we print needs to be transportable. So we are limited to the overall footprint of a single item that can be sent. But we found that when it's installed in the field, the portability is one. It's in favor of the worker that's ultimately maneuvering that individual aspect. And if something does go wrong over the course of an entire project, whether it's in construction or just something small like a landscape feature, it means you're not trashing the entire object, right? You can replace an individual component. One area that Volker and I differ a little bit is in the use case of his technology for housing. So we are piloting a modular house with his printer. And one of the considerations we have is, because of the quality that you're able to unlock in a controlled environment, we can further cut out downstream processes, right? Hopefully you don't have to stucco, or you can integrate a nice pattern into a facade that's already in a wall module. And by doing that, you're facilitating an overall shorter construction process, but you're giving the end client a aesthetic that they can be really happy with. So those are all, there's give and take of each method, but I think that the pros outweigh the cons in that specific scenario.
Thanks, Justin. So yeah, we only have about 5 minutes until we have to wrap this up. So I'm going to go to some of the questions that came from the audience. Saga has asked if there are some challenges with construction printing that limit the ability to add the accelerant to the print head.
So it's yes and no. We've had quite a few inquiries from gantry printers as well to add the accelerant to the printhead. From what I explained real quick, it's because of the viscosity or the flowability or the pumpability of the material, right? There's been stories in the industry of large scale printers having to pump so far and pressures building up to 40 bar and exploding, and you don't want that. It's just dangerous. So it's possible also on the larger machines, and you will be seeing that. In fact, there are a few in the market now that are site construction machines that have a two-component style technology. They exist, and that kind of helps. To add a little bit to the environmental factors as well, I saw a question go by about adding temporary environmental enclosures. We've seen this done in the industry as well, even for 2-story houses, but they are giant scaffolding tents that have to be built. And even then, humidity is hard to control. Wind is a big issue. Sunlight is a big issue. And these are mainly big issues because of shrinking of concrete, right? When the water is released from the concrete, you get shrinkage and get cracking. And when we do printing in-house, not only can we control those factors better, but once we've printed something, we can put it into a curing chamber where we have a high moisture, and so we can prevent cracking because concrete still needs to cure. So it's arguably, even from a structural point of view, it's better to print them in-house on a smaller scale to ensure the structural capabilities of the print, and to be able to monitor them on a print-by-print basis in the best way possible. And I'm a big fan of scaling up slowly. So coming from the controlled environment, that's when we can move to the real environment best from my perspective.
So a follow-up to that another person from the audience, Ragdad, had was, so with the prefab approach, have you guys faced any challenges to the on-site assembly, and what have been the biggest challenges around that? Yeah.
Justin's yours?
Yeah, sure. I mean, ultimately, it still comes down to field conditions. So we can have the perfect print in our facility, but if it's going on a slab, right, that predicates that the slab needs to be near perfect, which, as anybody who's in construction knows, that's seldom the case. And then just how different components align together. If you're doing something in modules, even a 5 millimeter over extrusion in one random area, as it butts up against another piece, right, it can cause misalignment. So it's stuff that we have to look out for, and we're getting really good at understanding what those relationships are and how to mitigate those factors. And then I think the obvious one that half the people in the audience are probably thinking about is price, right? I mean, you do have to ship heavy concrete items to site, whether that's in an architectural element or even something as simple as a planter, right? We sell planters and they weigh like 100 pounds a piece for something small. It makes logistics a challenge. But when you compare that against the cost of erecting a machine for one specific project versus having one in the facility that can go from project to project to project seamlessly, we think the cost is offset. So it's part of the grand experiment that we're all conducting now, right?
All right, I just have one more quick question. If you could just each provide like a 30-second answer to it. So what does the 5 next years look like for your companies, and what are the biggest like threats that you see forthcoming? So we'll start with Volker.
So for us, sorry. So for us, our machine is at a point where we really feel that it's off the shelf. So we're working a lot on upgrades. We have the color, which is a nice addition for some of the aesthetic appeal, and we're working on milling. To touch on what Justin said, to make millimeter perfect adjustments to modular construction. And we're going to continue to do that. And in that sense, it's scalable because we can put robots next to each other in-house and do project by project. Something you see with, for example, branch technology, which some of you might know. It's a large facility with multiple printers doing parts of a project to speed up lead time, etc. So that's where we're going to be going as an industry, increasing scale in prefab scenarios for larger and larger projects with more upgrades to be able to handle these in an automated way.
And
Justin,
on
quick
my,
follow to that.
yeah, so on my end, so I don't manufacture printers, right? But so for me, it's market penetration. I would like you know, everybody who's in the audience to be able to go to their closest city or hub and be able to interact with a 3D printed element that we produced. To us, you know, the 5-year prospect and outlook to that is to eliminate the last mile and deploy additional printers throughout the country so that we can facilitate and service projects regardless of where they are.
All right. Well, thank you so much to you both, Vertico and Printera, Justin and Volker, for your willingness to participate on this panel. I really enjoyed the conversation that we had, and we'll have to transition now to our next segment. Thanks again.
Thanks for having us.